What's happening, dogs? Mr. Allen here. We're about to solve for x in this beautiful, wonderful rational equation, and we're going to list any domain restrictions. Now, when solving rational equations, first thing I got to do is figure out my least common denominator, and to do so, I'm going to have to factor this guy right here. Anything that can be factored in my denominator needs to be factored, and I love factoring, man. What multiplies to 3 and adds to 4? Well, that's going to be 3 and, oh my goodness, look at that. Oftentimes, guys, with these problems, it is the other 2 that you have chilling in that problem. So look for those things if you're a little bit lost. Not a guarantee, right? But that is commonplace in this style problem. All right, so this is factored. This guy over here has that x plus 1. This one here has that x plus 3. It looks like my LCD is, in fact, this guy right here, x plus 3 times x plus 1. That's dope. All right, from there, I can also get my domain restrictions. Domain restrictions are anything that makes my denominator 0. Why? It's because I cannot divide by 0, so I have to put that in there and say, hey, man, no, we can't do that. All right, so what makes my denominator 0? Well, -3 and -1 would both make it 0. This guy here, same with that one. So x cannot equal -3 and -1. Excellent. Wonderful. All right. That's taken care of, out of the way. We're ready to rock and roll. Now, for this video, we are going to get common denominators throughout the problem, all right? So what I want is I want a common denominator for each one of these fractions. That's one strategy of doing this, and that's how we're going to do it in this video. So I'm going to multiply this one by whatever it needs to get my LCD, which is x plus 1. So if I'm multiplying my denominator by x plus 1, I also have to multiply my numerator by that x plus 1 to keep things equivalent, right? What's multiplying by x plus 1 over x plus 1? Anything divided by itself is 1. What's anything times 1? It is that anything. So multiplying by 1 does not change something. We are multiplying by 1, technically, so it won't change its value, if you will. All right, so that's why we're able to do that. That's why it's like a legal mathematical move. It's not just magic, like, why can you do that, but I can't do this? That's why we're multiplying by 1. Enough on that. All right, so now I have, this guy here is set, but this one over here needs an x plus 3 over x plus 3, right? That way I'll get my denominator to be the same thing. All 3 of these will be the same. So now, wonderful children, I'm going to rewrite this bad boy all with the common denominators. It's quite a bit of writing. We've got 2 times x plus 1 over x plus 1 times x plus 3. The next one, we have 3x plus 5 over that x plus 1 times x plus 3. I'll just rearrange it so they all look exactly the same, right? We want them to look perfect. All right, wouldn't matter if those are switched, though. And then this last one here, I've got 5 times x plus 3 divided by, and we got x plus 1 times x plus 3. Woo! That's a long problem. All right. So my denominators, they're all the same, aren't they? Now let's see if this makes mathematical sense. If my denominators are all the same or equal, would it make sense that I can just figure out how to get my numerators equal and we're all Gucci? Yes, that is in fact the case, all right? So I can drop all my denominators, woo, my voice. I can drop all my denominators here and just figure out what x value will make my numerators equal. So for the first one here, I've got 2 times x plus 1 minus, and I'm going to throw some parentheses here. Reason being, we need to subtract both of these terms, all right? Then I got 5 times x plus 3. Beautiful. Let's distribute that 2. We get 2x plus 2. Here I'm going to distribute that negative. It's going to be minus 3x minus 5 equals, and I got 5x plus 15. All right. We got all sorts of x's and things, and let's combine some like terms. Let's clean this up. 2x and negative 3x is negative x. 2 and negative 5 is going to be negative 3. This side is all good. All right. Now what I'm going to do is I'm going to add x to both sides. So add x. All right. And then that's going to give me 6x over here. I wanted it positive, right? We could have subtracted 5x. We just have negative 6x on the other side. Your call, right? I'm just doing it, so I get to choose. All right, and I'm going to subtract 15 so I can get x on its own side, and I get negative 18. So now when I divide by 6, I get x equals negative 3. Before I circle this, I got to double check over here, make sure it's not one of my domain restrictions. Uh-oh, spaghetti-o. It is a domain restriction. So this is, in fact, extraneous. Okay, yes, that is a real word, extraneous. It's an extraneous solution. So in this particular problem, in this one here, I'm going to do this in a different color. It is no solution. All right, no solution, unfortunately, that'll work and make these two sides equal to each other, because the value that does it causes 0 in my denominator, which is no bueno, right? We can't have that. So no solution on this one. That's unfortunate. I guess it really doesn't matter, but you know, like you kind of want to have an answer, right? I get that. So you guys have a wonderful day. Hope this all makes sense and was a lot of fun. I had tons of fun. All right, see you later.